Hello everybody, this is Dr. Nurbat Shah from University of Engineering and Technology, Peshawar. It's a second part of the video in which we are talking about limit of a function. In this video, I'll be mainly talking about one-sided limits. That is, I'll be talking about how do we find left-hand limit and right-hand limit of a function. Usually consider two types of functions. One is usually considered as a unit step function, a function which is defined by a single formula in all its domain. And the second type of functions are piecewise defined functions, which are defined by different formula in different intervals in the whole domain. So in both cases, usually we use different type of technique method to find left-hand limit and right-hand limit. So I'll be explaining that in this video. So if a function is a unit step function, as I said earlier, then the left-hand limit, which is denoted by limit x goes to a, and then we put bar on it if of x, that is equal to limit h goes to 0. We basically replace this limit x goes to a from left side. This is the symbol used for left side limit f of x. What do? We replace this limit x goes to a by h goes to 0 with replacing x everywhere in the function by a minus h with imposing a condition that h is greater than 0. And why do we do that? If you consider a point A, let's suppose this is point A, and we want to find a left-hand limit, so it means we'll be taking all points to the left of this point. So if we consider, let's suppose this is my point, so this point is x, so this distance is what? This is basically x minus a in this case, right? So we could write this x as, you see, if we write this x as what? You are just to the left of a, so we may write this x will be replaced with a minus h, because we just to the left of a, so we have x is equal to a minus h. If you are to the right of this a, so we could write any point to the right of a, that would be written as a plus h. I'll be using this in the next step. So that's why we replace x in the given function with a minus h by taking h goes to 0, because as we take h goes to 0, what is going on? We will be we will be getting closer to this point. You see, h is going towards 0, so we are there, and so on. So जैसे जैसे ये h small होता जाएगा, it is moving towards 0. This point will be moving towards this point A. So it's the same thing, just giving you the direction of limit, that whether we are from the left side or from the right side. So the right hand limit will then be defined as limit x goes to a to positive side f of x, that is equal to, it's not just like a positive side, it's the right side. So f of x, that will be same as I explained earlier, replacing limit x goes to a through positive side by limit h goes to 0, and replacing x with a plus h everywhere. Wherever you see x in the function, that would be replaced with a plus h, whereas in case of left-hand limit, this x will be replaced with a minus h. And then applying at the end limit h goes to 0 instead of going for limit x goes to a. If we have a piecewise defined function, like the function is defined in different intervals differently or by different formula, so in that case, if you want to find left-hand limit, so the notation is same. You see x goes to a, but what do? The first step is we just want to get rid of this symbol, so we take x goes to a, but immediately you impose the condition that x will be less than a, means that जो फंक्शन f ऑफ x लेस देन a के लिए डिफाइंड होता है, उसी फार्मूले को आपने यूज़ करना है फॉर लेफ्ट हैंड लिमिट. एंड इन केस ऑफ राइट हैंड लिमिट हम क्या करेंगे? हम उस फार्मूले को यूज़ करेंगे जो कि x ग्रेटर देन a के लिए वो फार्मूला डिफाइंड होगा. Okay, so in case of right hand limit, we just get rid of this plus, and this limit becomes x goes to a, and then it will give you we will use a function which is defined for x greater than a. Okay, I'll just explain that by solving some questions from Thomas' book. So if you have still any question, you can just place a comment, so I'll get back to you. Okay, so for existence of limit, you must know that, you should note that left hand limit and right hand limit, this should be same if we say the limit at that point exists. So left hand limit should be equal to right hand limit if we have to check, or whether we have to prove, or we have to verify that limit x goes to a, f of x exists. अगर किसी पॉइंट पे लिमिट एग्जिस्ट करेगा तो उस पॉइंट पे लेफ्ट हैंड लिमिट का राइट हैंड लिमिट के बराबर होना ज़रूरी है. Okay, so let me do some questions from Thomas book. That's exercise 2.4, जिसमें मोस्टली हम बात कर रहे हैं वही लेफ्ट हैंड लिमिट और राइट हैंड लिमिट से रिलेटेड, या लिमिट के एग्जिस्टेंस के बारे में हम बात कर रहे हैं उस केस में. So the question 1 is, which of the following statements about the function y is equal to f of x graphed here are true, and which of them are false? Right, so in this case, when we say finding left hand limit at a certain point, so it means we have to approach to that point from the left side, and if you want to find limit at the right, from the right side, so we'll be taking these points and checking behavior of the function, that where is that function going, right? So that will be basically defining you or giving you right hand limit and left hand limit. The concept is same what we discussed in last video. So the first question is saying limit x goes to -1 from right side, f of x is equal to 1. So this is our point where we want to check limit of the function. So if you want to approach to this point from right side, where is this graph going? You see the graph is moving towards 1. So that means this is true. So right hand limit at x equal to -1, that is 1, and that's true. Whereas say that limit x goes to 0, the next one from left side, f of x, that is going towards 0. So if you approach to 0 from left side, you see this is the left side at 0, and the graph is also going towards 0. So it means this is also true. And then it says that limit x goes to 0, the same limit, but at this moment it says it is 1. So it cannot be true, because limit at a point, if it exists, that's always unique. So if it is 0, it cannot be 1. But value at this point, you see that that is 1. Limit at this point is 0, but exactly at this point the value of function is 1. So they are basically mixing up these two statements. यहाँ पर ये f of 0 है और ये इसके लिमिट की बात हो रही है, तो ये सेम नहीं है. In part D, this says that left hand limit and right hand limit both are same. If you see, wherever we have a jump at a point in a graph like this one, in that case left hand limit and right hand limit, they are not same. Geometrically हम बात कर रहे हैं. तो यहाँ पे अगर आप देखें तो यहाँ पर कोई भी जंप नहीं है. तो अगर हम लेफ्ट हैंड लिमिट की बात करें, हम राइट हैंड लिमिट की बात करें, तो इन दैट केस ये यहाँ पे सेम आ रहा है. सो लिमिट एट दिस पॉइंट ऑब्वियसली एग्जिस्ट, एंड लेफ्ट हैंड लिमिट, राइट हैंड लिमिट, दे आर सेम. So this statement is also true. Okay. So in this case, if left hand limit and right hand limit both are true, so limit at that point would exist. As I said earlier, कि अगर किसी भी पॉइंट पे फंक्शन का लिमिट एग्जिस्ट करेगा तो उस पॉइंट पे लेफ्ट हैंड लिमिट, राइट हैंड लिमिट सेम होंगे, एंड वाइस वर्सा. तो यहाँ पे आप पार्ट डी से देख सकते हैं, यहाँ पे हमने इसको ट्रू कंसीडर किया कि लेफ्ट हैंड लिमिट और राइट हैंड लिमिट दोनों बराबर हैं, तो देयरफॉर लिमिट एट दिस पॉइंट एग्जिस्ट. सो दिस इज आल्सो ट्रू. And limit at this point is 0, so the answer is again yes, because left hand limit at this point is 0. It is approaching towards 0 as we approach to 0 from left side. It approaches to 0 as we approach to 0 from right side. So left hand limit and right hand limit both are what? They are 0. So limit x goes to 0 is 0. That is also true. Whereas in G we say limit x goes to 0 f of x that is equal to 1. But we concluded that limit at this point is 0 and we said that is true. So it cannot be 1 because said earlier that limit if exists a point that will be unique. So it cannot be 1, okay? You see, value of the function at this point is 1, limit is what? That is 0. Now we talk about limit at x equal to 1 in part H. What would happen at limit x equal to 1? It says it's 1. But you see, does limit exist at that point? The answer is no, because the left hand limit is what? It is 1. As we move towards 1 from left side, it is going towards 1. Whereas if you move from the right side, the graph is on x-axis, it means the value will be 0. So from this side limit is 1, whereas from right side limit is 0. So दोनों सेम नहीं है. या आप यहाँ से देख सकते हैं कि इस पॉइंट पे जंप है, जहाँ पे भी जंप होता है वहाँ पे लिमिट एग्जिस्ट नहीं करता. अगर लिमिट एग्जिस्ट नहीं करता तो वो 1 कैसे हो सकता है? तो लिमिट डज नॉट एग्जिस्ट एट दिस पॉइंट. Limit x goes to 2 from left side f of x is equal to 2. Now we talk about x equal to 2. As we approach to 2 from left side, because we talk about left hand limit, the graph of the function is along x-axis, you see, and on x-axis value of function is always 0. So it means this limit is not 2, this is basically what? This is 0. So left hand limit at x equal to 2 from left f of x, that is 0, not 2, so this is false. In part K, it says limit x goes to -1 from left side, f of x does not exist. So if we talk about limit at x equal to -1 from left side, so if we approach to -1 from left side, you see there is no function defined here, there is no graph defined here, so this is true. It means limit doesn't exist. Where if you approach to 2 from right side here, if you approach to 2 from right side, its value is 0. So this is false as well, because function on the right of this 2 does not exist. Function defined नहीं है, तो वहाँ पे limit जो है वो 0 नहीं हो सकता. Left hand limit जो है वो 0 हो सकता है, right hand limit जो है वो 0 के बराबर नहीं हो सकता. The same thing we talk about limit at different points in this question as well. Again, we say which of the following are true and which of them are false. So in part A, again, it says that limit x goes to -1 from right side, f of x is equal to 0. So 1, sorry. So if you approach to -1 from right side, the graph is going towards 1, okay? So that is true, right? Limit x goes to 2, f of x does not exist. So if we approach to 2 from either side, you see, from this side or from this side, the graph is going to a single point, and that point is what? It is 1. You see, at this position the value is 1. So limit at this point 2, it exists. लेकिन यहाँ पे कह रहे हैं कि डज नॉट एग्जिस्ट, जिसका मतलब है ये फॉल्स है. हाँ, इस पॉइंट पे वैल्यू जो है वो 2 के बराबर है, लिमिट जो है वो 1 के बराबर है. ज्योमेट्रिकली एक सिंपल सी बात है कि जिस पॉइंट पे भी जंप आता है, अब जैसे ये जंप नहीं है, राइट, इट्स अ होल, ये जंप है. अगर हम 1 पे बात कर रहे हैं तो यहाँ पे जंप है. तो अगर आपको ज्योमेट्रिकली देखना है कि किस पॉइंट पे फंक्शन का लिमिट एग्जिस्ट कर रहा है, किस पॉइंट पे एग्जिस्ट नहीं कर रहा है, या किस पॉइंट पे लेफ्ट हैंड लिमिट और राइट हैंड लिमिट बराबर नहीं है, अगर किसी पॉइंट पे जंप आता है तो वहाँ पे लेफ्ट हैंड लिमिट और राइट हैंड लिमिट दोनों बराबर नहीं होते. तो यहाँ पर, और ये ध्यान में रख लें कि ये जो हमारे पास आता है ना 2 पे जिस तरह से है, तो 2 पे यहाँ पे ये जंप नहीं है, ये होल कैसे कंसिडर होता है. इवन तो इस पॉइंट पे वैल्यू वो यहाँ पे आ जाती है. अच्छा, अब यहाँ पर कह रहे हैं कि इस पॉइंट पे लिमिट 2 के बराबर है. तो इसी एज आई एक्सप्लेन, यहाँ पे लिमिट जो है वो 1 के बराबर है. इन बोथ फंक्शन की वैल्यू यहाँ पे 2 के बराबर है, लिमिट 1 के बराबर है. तो अगेन इट इज़ फॉल्स. इफ़ यू अप्रोच टू 1 फ्रॉम लेफ्ट साइड, पॉइंट 1 की बात हो रही है, अगर हम यहाँ से अप्रोच कर रहे हैं तो ये क्या पे जा रहा है, ये 2 की तरफ जा रहा है. ये ग्राफ जो है दैट इज़ मूविंग टूवर्ड्स 2, सो इट इज़ ट्रू. वेयर एज लिमिट x goes to 1 from right side, it is going towards 1, so the answer is again it is true. बिकॉज इफ अगर हम 1 को अप्रोच कर रहे हैं तो ग्राफ यहाँ पे किधर जा रहा है, इस पॉइंट की तरफ जा रहा है, और ये पॉइंट कौन सा है, दैट इज 1, सो दिस इज आल्सो ट्रू. Limit x goes to 1, f of x does not exist, and that's obvious because left hand limit and right hand limit both are not same, so limit in this case does not exist, so it's true. At x equal to 0, if we talk left hand limit and right hand limit both are the same. You see that? अगर हम left से बात करें या right से बात करें, again there is no jump at this point 0, so it means left hand limit and right hand limit both should be same, so this is also true. Limit x goes to c f of x exists at every point c in the open interval -1 to 1. If we talk about -1 to 1 from here to here, do we have any jump in this case? So the answer is no, we don't have any jump in this interval. So therefore, we say it is continuous everywhere in this interval. So the statement is true. And again, it says about the same function at a point c in the interval 1 to 3. So the answer is yes, it is again 1 to 3. We see there is no jump in the graph of the function. So it is also true. Limit x goes to -1 from left side f of x 0. So if you see on the left side of the point x, the function is not defined. So this limit cannot be 0. So it's false. And at 3 from right side does not exist. So the answer is yes, because the function is not defined here. So if the function is not defined, how could we say limit is defined? So the answer is again, the last one is what? This is true. Okay, let's move to the next question. That's question number 3. F of x is given, and also we are given a geometry as well. So we need to find limit x goes to 2 from right side, from left side. Then we are asked if limit x goes to 2, f of x exists or not. So I'll be solving this problem or this question mathematically, rather than just considering the limits. The graph. If you see the graph at limit x goes to 2, it doesn't exist, we are having jump. So we need to prove that analytically, mathematically, that limit at this point does not exist. So I'll find limit x goes to 2 f of x from left side. So in this case, as I said, it's a piecewise defined function, so I'll just write limit x goes to 2 f of x, and with immediate condition that x is less than 2. And for x less than 2, the function is defined as limit x goes to 2, the function is 3 minus x. So if you put limit there, that will give you 3 minus 2, which is equal to 1. So left hand limit of this function is what? That is 1. And if you find right hand limit, so limit x goes to 2 from right side f of x, as I explained earlier, that the rule is what? You just remove this plus and applying the condition that x will be greater than 2. So for x greater than 2, the function is defined as limit x goes to 2, the function is x divided by 2 plus 1, and if you put this limit, you get 2 divided by 2 plus 1 is equal to 2. So you see left hand limit is what? The first question is say finding right hand limit and left hand limit. So right hand limit is 2, whereas left hand limit is 1. They are they same? The answer is they are not same. So does this limit exist? So you would say no, this limit does not exist. This is false, this is true. And why not? Because the left hand limit and right hand limit both are not same. Okay. And the part C, in part C there says what about limit at x equal to 4? So we can find limit at x equal to 4 as well. Again, I'll find limit x goes to 4 from left side f of x. By definition of the left hand limit, as I said, we just remove this bar, taking f of x as it is with condition that x is less than 4. Now keeping in mind for x less than and greater than 4, we will be using same function, you see, because x greater than 4, x equal to 4, that is lying in this domain. So to the left of 4 and to the right of 4, the function will be defined by this formula. Excuse me. So what would have in this case, you just write limit x goes to 4, and function in this case will be simply x divided by 2 plus 1, which would give you 4 by 2 plus 1, that is equal to 3. Whereas if you find right hand limit, limit x goes to 4 from right side f of x, again by using definition we would write that x goes to 4 f of x with condition that x is greater than 4. And in this case, the function will remain same. Limit x goes to 4. F of x is what for x greater than 4? That is again x by 2 plus 1. And as done previously, that would give you same limit. So in this case, say, does this limit exist? So the answer is yes, right? In this case, this is true. So we have to go for it. So what is it? The limit in this case will be 3. Limit x goes to 4 altogether f of x that is equal to 3. यहाँ पर एक पॉइंट नोट कर लें कि जिस पॉइंट पे इंटरवल स्प्लिट होता है, जैसे यहाँ पर 2 पे इंटरवल स्प्लिट हो रहा है, तो इस पॉइंट पे अगर हम लेफ्ट हैंड लिमिट को फाइंड करेंगे तो आपने इस फंक्शन को यूज़ करना है, अगर राइट हैंड लिमिट को फाइंड करना है तो आपने इस फंक्शन को यूज़ करना है. इसके अलावा एनी नंबर विच इज़ ग्रेटर देन 2, कोई भी नंबर आप ले रहे हो, इवन तो आप 2.1 ले रहे हो, तो 2.1 पे भी लेफ्ट हैंड लिमिट के लिए क्या करना है, आपने इसी फंक्शन को यूज़ करना है. राइट हैंड लिमिट के लिए भी इसी फंक्शन को यूज़ करना है. आप 10 ले रहे हो, 10 पे लिमिट फाइंड करना चाहते हो, तब भी लेफ्ट हैंड लिमिट के लिए आपने इसी फंक्शन को यूज़ करना है. राइट हैंड लिमिट के लिए भी आपने इसी को यूज़ करना है. एंड एनीथिंग विच इज़ लेस देन 2, okay, for less than 2 anything, in that case what would you do? You would be using this formula all the time. Like अगर आप 1 पे लिमिट फाइंड करना चाहते हैं तो उस केस में आपने दोनों केस में, चाहे लेफ्ट हैंड लिमिट हो चाहे राइट हैंड लिमिट हो, यू विल बी यूजिंग दिस फार्मूला. तो एनीथिंग जो कि 2 से कम है और आप उस पॉइंट पे लिमिट फाइंड करते हैं, तो दोनों के लिए लेफ्ट हैंड लिमिट राइट हैंड लिमिट दोनों के लिए आपने इसी फार्मूले को यूज़ करना है. एंड एनीथिंग ग्रेटर देन 2, उसके लिए दोनों केस में आपने इस फार्मूले को यूज़ करना है. Same behavior in this case as well. So you see, if you want to find limit at x equal to 2 from right side, so right hand limit at x equal to 2, as I said, immediately you just remove this plus from the 2 and impose condition that x will be greater than 2. Now for x greater than 2, the function is defined as, that is x by 2. That is 2 divided by 2 is equal to 1. Because for x greater than 2, the function is defined as x by 2. Limit x goes to 2 from left side, f of x. By using definition, x goes to 2 f of x with condition that x is less than 2. For x less than 2, the function is defined as 3 minus x. So we take limit x goes to 2, 3 minus x, and then putting the limit, so we get 1 again. So in this case, left hand limit is same as right hand limit. That is 3 and this is also 3, sorry 1, not 3, both limits are 1. So this is 1 and this is 1, so that means they are same. So अब देख सकते हैं यहाँ पर कि इस पॉइंट 2 पे कोई जंप अभी नहीं है, तो ये लिमिट यहाँ पे एग्जिस्ट कर रहा है. So this limit exists. What is about f of 2? तो f of 2 is defined from the function here. ये x equal to 2 पे वैल्यू है, ये x less than 2 के लिए और x greater than 2 के लिए. So what about f of 2? So f of 2 that is equal to, in this case that is equal to 2. Limits इसके 1 आ रहा है, लेकिन फंक्शन की वैल्यू जो है वो 2 के बराबर है. तो क्या लिमिट एग्जिस्ट कर रहा है? The answer is yes. And what is that? That is 1. And what about the value at this point? That is equal to 2. We can do same thing for x equal to -1. So अगर हम -1 पे बात करेंगे तो चाहे हम लेफ्ट हैंड लिमिट फाइंड करें चाहे हम राइट हैंड लिमिट फाइंड करें, in both cases we will be using this function 3 minus x as I explained earlier. So you may pause the video and do part C, practice part C and D yourself. You will be getting answer 4 in both cases, because at x equal to -1 the limit is what? That is 4. So you should get 4 from left hand limit, right hand limit, because for left hand limit at x equal to -1, the right hand limit at x equal to -1, आपने function same use करना है जो कि 3 minus x होगा. Right, so this is another function given, and in this case it says that f of x is 0 when x is less than or equal to 0, and it is sin 1 over x when x is equal to greater than 0. So does limit x goes to 0 f of x exist from right side? So from right side you see that we are having oscillating function, and I explained in last video that whenever we have oscillating function, limit doesn't exist. So for right hand limit at this point, that doesn't exist. What about the left hand limit? So left hand limit is very clear, it's just moving as we move towards 0, the graph is also moving towards 0, or if you take anything left after 0, you will be getting what? You will be getting 0. So left hand limit is what? That is 0. Right hand limit does not exist. Now what about all limit? So it also does not exist, because लेफ्ट हैंड लिमिट राइट हैंड लिमिट दोनों का सेम होना ज़रूरी है. तो यहाँ पे ऑब्वियसली लेफ्ट हैंड लिमिट जो है वो तो 0 के बराबर है, राइट हैंड लिमिट जो है वो एग्जिस्ट नहीं कर रहा, देयरफॉर ऑल टुगेदर ये लिमिट एग्जिस्ट नहीं कर रहा. In this case, it's again, does limit x goes to 0 from right side exist? So the answer is yes. In this case, it does exist, because you see that as we get close to 0, what is going on? The function in blue, that is getting closer towards 0 0 0. So जो oscillations थे पिछले केस में sin 1 by x के, it because of under root x वो क्या हो रहे हैं? वो कम होते जा रहे हैं, and as such as x goes to 0, x absolute is what? That is going towards 0. So x under root is going towards 0. So therefore what happens? ये इसका जो right hand limit है in this case, that would be 0. And that exists. The answer is yes, that is 0. What about left hand limit? Because of square root of x, a square root is defined for positive values only. So in this case, x is not defined, under root x is not defined for negative numbers. So therefore the left hand side अगर आप देखें तो function defined ही नहीं है. So therefore यहाँ पे function का left hand limit exist नहीं करेगा, and then altogether इसका limit exist नहीं होगा. Right. So can we draw this function f of x is equal to x cube when x is not equal to 1, and it is 0 when x is equal to 1. So what do? We simply draw the graph of x cube, right? I hope everybody knows that how to draw graph of x cube. So it is something like that, right? You see. So this is the graph of not exactly the same function what we are asked. This is a better way I'm drawing it. So it's a graph of y is equal to x cube, right? But you see, it says that if x is equal to 1, then you take its value to be 0. Okay, so let's suppose this is my 1 here. So at x equal to 1, this value should be basically 1. x cube में ये value 1 के बराबर है, लेकिन यहाँ पे क्या हो रहा है? यहाँ पे ये कह रहे हैं कि जब x 1 हो तो इसकी वैल्यू क्या ले लो? इसकी वैल्यू फिर आपने 0 लेनी है. तो ये इसका ग्राफ हो जाएगा. यहाँ पे होल आपने छोड़ना है, ठीक है? यहाँ पे इसकी वैल्यू आ जाएगी. Now it says that what about the limit x goes to 1 from left side? So if you want to find that mathematically, so again it's same thing for left hand limit. X goes to 1 from left side, f of x, you will be taking same function x goes to 1 x cube. Because for x not equal to 1, that means for x less than 1 and x greater than 1 both, the function is defined as x cube, and exactly x equal to 1, it is defined as x equal to that is 0. So limit is what? In this case is 1, that's 1 cube is equal to 1. And for right hand limit, it's again the same thing, f of x, we will be taking x goes to 1 when x is greater than 1. So that is again x cube, so we get 1. So left hand limit, right hand limit both are same, and so this limit also exists, and that is equal to 1. Exactly इस point पे जो value है at x equal to 1, that will be 0. Whereas for limit, left hand limit, right hand limit दोनों के लिए आपने x cube को use करना है. सेम थिंग फॉर क्वेश्चन नंबर 8. आई वुड जस्ट सजेस्ट कि आप वीडियो को पॉज कर दें और इस क्वेश्चन को फिर खुद करें, बिकॉज इसमें अगेन द सेम थिंग, लेफ्ट हैंड लिमिट और राइट हैंड लिमिट दोनों के लिए आपने इसको यूज़ करना है, एंड एग्जैक्टली x इक्वल टू 1, इसकी जो वैल्यू है वो 2 के बराबर है. दैट्स द ग्राफ ऑफ 1 माइनस एक्स स्क्वायर विच इज़, अगर किसी को ग्राफ में प्रॉब्लम होता है तो ये एक्स स्क्वायर का ग्राफ यूँ होता है, ठीक है, arbitrarily, and 1 minus x square, that basically you have to shift this graph 1 unit upward, something like that. Shape will remain same, so it will be that. लेकिन अब क्या कह रहे हैं कि जब x1 के बराबर हो तो x1 पे इसकी वैल्यू यहाँ पे आ जाएगी, लेकिन ये कह रहे हैं कि नहीं, आपने इसको 1 नहीं लेना, आपने इसको 2 लेना है. तो मे बी गोइंग टू दिस इज 1, दिस इज 2, तो समवेयर यहाँ पे आपने इसको बोल्ड करना है. बाकी then that's same thing for left hand limit, right hand limit. In both cases you will be using the same formula, 1 minus x square. In question 9 and 10, they are asking about some questions. First one is, what are the domain and range of the function f? And at what point c, if any, does limit x goes to c f of x exist? at what point does the left hand limit exist but not the right, and at what point does the right hand limit exist but not the left hand limit exist. Okay. So first we talk about domain and range of this function. I talk about the first one. You may practice the second question then yourself. So you see, in the first interval, or in the first part of the domain from 0 to 1, we are given 1 minus x square. So keeping in mind, domain of 1 minus x square is usually minus 1 to 1, right? So but we are given that we only use this for 0 to 1. So in the first part, its domain will be 0 to 1 excluding 1, where in the second part it said domain is what, that is 1 to 2. So that include 1, right, excluding 2 there, but then it is given that 2 is also included. So altogether the domain is starting from 0 and going up to 2. So domain अब यहाँ से देख सकते हैं 0 से स्टार्ट हो रहा है एंड एवरीथिंग इज इंक्लूडेड बिटवीन 0 एंड 2, 2 पे ख़त्म हो रहा है, तो इसका डोमेन जो होगा वो 0 से लेकर 2 तक होगा। अब इसका रेंज की हम बात करेंगे, तो रेंज के केस में आप देख सकते हैं कि यूजुअली जो ये जो फंक्शन है ना, ये सेमी सर्कल होता है। y इज इक्वल टू 1 माइनस एक्स स्क्वायर, इट्स अ सेमी सर्कल विद रेडियस दैट इज इक्वल टू 1। तो अगर हम इसका ग्राफ ड्रा करना चाहें तो समथिंग लाइक दैट यूँ होगा। तो इसका रेंज यहाँ से यहाँ तक होगा, रेडियस इसका 1 के बराबर है, इसका मतलब इसकी वैल्यू 0 से स्टार्ट होती है 1 तक जा रही है। लेकिन यहाँ पे थोड़ा सा प्रॉब्लम है कि इसमें इन्होंने कहा है कि 1 आपने नहीं लेना। ओके, तो इसका मतलब यह है कि इस फंक्शन की वैल्यू यहाँ से 0 नहीं हो सकता। ठीक है, तो इसकी जो वैल्यू है वो अगर हम सिर्फ 1 माइनस एक्स स्क्वायर की बात करेंगे, अगर आप ये इंक्लूड कर देते हैं तो इसका रेंज जो होता है वो 0 से 1 तक ही होगा, फ्रॉम 0 टू 1। लेकिन जब आप ये फंक्शन लेंगे तो उस केस में आप देख सकते हैं 1 इंक्लूड नहीं है इसके डोमेन में, इस फंक्शन के डोमेन में, तो इसका मतलब यह है कि इसकी वैल्यू कभी 0 नहीं हो सकती। तो इस पार्ट से क्या आ जाएगा, हमारे पास जो रेंज आएगा वो एक्सक्लूडिंग 0 एंड गोइंग अप टू 1 बिकॉज ऑफ द सेमी सर्कल। Whereas the second part is saying from 1 to 2 the function is 1, so the value is 1, so range will be only 1, producing 1 only. And then it gives you what, that giving you the third part is constant, when x equal to 2 it is 2, so that give you 2 value as well, can give you 2 value as well. So altogether we could write that is from 0 to 1 including 1, and then we have union 2. Keeping in mind इसको आपने 0 से लेकर 2 तक नहीं लिखना, ये बात समझ लें आप इसको। ठीक है, अब इसको अगर हम ग्राफ करेंगे, लेट मी ग्राफ द फंक्शन इज वेल, एंड देन फ्रॉम ग्राफ यू वुड सी कहाँ पे लिमिट एग्जिस्ट कर रहा है और कहाँ पे लिमिट एग्जिस्ट नहीं कर रहा। इन द फर्स्ट पार्ट दे आर सेइंग ग्राफ द फंक्शन इज वेल, लेकिन ग्राफ के लिए पहले ज़रूरी है कि आपको उसके डोमेन और रेंज का पता हो। सो इफ़ यू वांट टू ड्रा द ग्राफ ऑफ दिस फंक्शन, सो फर्स्ट इन द फर्स्ट इंटरवल फ्रॉम 0 to 1, दिस इज 0, this is 1. So from 0 to 1 at x equal to 0 it is what, that is 1, sorry, and this is as I said it's a quarter circle is a whole। अगर हम इसके डोमेन में बात कर रहे हैं -1 से लेकर 1 तक, तो वो रिप्रेजेंट करता है सेमी सर्कल को। लेकिन आगे अब ये क्या है, ये सिर्फ 0 से 1 तक है, तो ये क्वार्टर सर्कल हो जाएगा। तो दिस इज हियर, एंड इसी यहाँ पे क्या हो जाएगा, होल आएगा, बिकॉज 1 पे उसकी वैल्यू 0 नहीं है, वो इस डोमेन में नहीं होगा। फिर इसके बाद फ्रॉम 1 to 2, its value is what, that is starting from here, so you see that's like that, and at x equal to 1 again इसकी वैल्यू 2, इसकी वैल्यू जो है वो इसके बराबर नहीं है, तो you see that one, and then at x equal to 2 the value is what, that is 2. This is the graph of this function. Now you see that कहाँ पे इसका लिमिट एग्जिस्ट करता है, at what point, see if any does limit exist. So you see from 0 to 1 limit exist, 1 पे exist नहीं कर रहा, then 1 से 2 तक exist कर रहा है, 2 पे as a whole limit exist नहीं हो रहा, तो हम left hand limit और right limit की बात कर रहे हैं। तो limit exist everywhere from 0 to 2 except 1, because 1 पे jump आ रहा है। तो अब यहाँ पे कह रहे हैं कि at what point does left hand limit only exist? So at x equal to 2, at x equal to 2 only left hand limit exists, right hand limit does not exist. Where at x equal to 0, right hand limit exists, but left hand limit does not exist. So that's they are asking about these questions. Pause the video for a while and try to solve this question number 10 yourself. Practice it. Okay. Now, in case of single step functions or unit step function, how do we do that? How do we find this left hand limit and right hand limit? So we'll be using this formula, limit x goes to a from right side f of x. So we'll be taking limit h goes to 0 f of a plus h. Whereas for left hand limit, limit x goes to a from left side f of x, that will be limit h goes to 0, and we just replace everywhere x by a minus h, keeping in mind in both cases h will be taken as positive. तो यहाँ पर आप इसी concept को use करेंगे. So if you do question number 11, it's a very simple one. Limit x goes to minus 0.5 from left side, and then we have under root x plus 2 divided by x plus 1. So what would we do? It will take limit h goes to 0, as I said, and we replace x by 0 minus 0.5 minus h plus 2 divided by minus 0.5 minus h plus 1. After simplification, we get limit h goes to 0 under root 1.5 minus h divided by 0.5 minus h. Then applying this limit, you will get what? Limit h goes to 0. That give you what? Under root 1.5 divided by 0.5, which is under root 3. So limit of this function will be simply under root 3. I presume, yeah. Well, in question number 12, they are asking about right hand limit. So limit x goes to 1 from right side, x minus 1 divided by x plus 2. So by using same concept, limit h goes to 0 under root 1 plus h minus 1 divided by 1 plus h plus 2, which will give you limit h goes to 0, 1 and 1 will cancel each other, so we get under root h divided by 3 plus h, and then putting h equal to 0, we get limit 0. Now what would happen? In this case they have not asked, लेकिन अगर हमसे पूछा जाए कि what about limit x goes to 1 from left side, the same function. So in this case अगर हम बात करेंगे इसके डोमेन की, तो इसका डोमेन जो होगा हम कहेंगे भाई x minus 1 must be greater than or equal to 0. So it is defined for x greater than or equal to 1. It is not defined for x less than 1. So therefore इसका जो left hand limit है वो exist नहीं करेगा. It doesn't exist in this case. ठीक है, तो ये आपने ध्यान में रखना है कि जिस पॉइंट पे हम लेफ्ट हैंड लिमिट या राइट हैंड लिमिट फाइंड कर रहे हैं या एज ए होल लिमिट फाइंड कर रहे हैं, क्या उस पॉइंट पे फंक्शन जो है उसका लेफ्ट साइड और राइट साइड पे फंक्शन डिफाइंड भी है या डिफाइंड नहीं है. I'll just ask you to pause the video for a while and do question number 13 yourself. Very straightforward है. इसमें again h goes to 0 and replacing x by minus 2 plus h everywhere, and then see what happens to the final limit. In question 14, the same thing. We are interested to find limit x goes to 1 from left side. So I would just ask to pause the video and solve this question again. I'm just trying to solve question 15. In this case, we are finding limit h goes to 0 from right side, and that is under root h square plus 4h minus 5 plus 5 minus under root 5 divided by h. You can still use h here. Limit h goes to 0 and replacing h everywhere by 0 plus h. So we can have 0 plus h square, 4 into 0 plus h plus 5 minus under root 5 divided by 0 plus h. And then we have limit h goes to 0, we get exactly the same thing back. H square plus 4h plus 5 minus under root 5 divided by h. Now if you put h equal to 0 directly, we get 0 by 0 form. So what would we do? We will be rationalizing it. So limit h goes to 0 under root h square plus 4h plus 5 minus under root 5 divided by h multiplying by its conjugate. So we get h square plus 4h minus 5 minus under root 5 को रिप्लेस करना है प्लस के साथ. तो अंडर रूट h square plus 4h minus 5 plus under root 5. So you'll get what? A minus b and a plus b. So that would give you square of this quantity. So we have h square plus 4h plus 5 minus 5 divided by h into under root h square plus 4h minus 5 plus under root 5. Cancelling these two together, and then we can take h common from it. So we have limit h goes to 0, h, that is h plus 4 divided by h into this whole quantity again. Under root this one plus under root 5. We cancel these together, and then applying limit h goes to 0, so we get 4 in the numerator, whereas in denominator we get 2 under root 5. अगर हम यहाँ पे 0 पुट करेंगे तो ये 0 हो जाएगा, ये 0 होगा तो ये टर्म ख़त्म हो जाएगा, राइट. दिस इज प्लस 5 और यहाँ से क्या हो जाएगा प्लस 5, सो अंडर रूट 5 आ जाएगा. अंडर रूट 5 so we get 2 under root 5 and then we cancel these together to get the answer 2 by under root 5. Right? You do same thing in question number 16 as well. पहले आप इसमें आपने h को रिप्लेस करना है 0 माइनस h के साथ और बाकी फिर आपने सेम यही चीज़ करनी है. Let me do question number 17 for you. So in 17, what do? We are given a function and we want to find left hand limit. Similarly, in case of right hand limit, in part B, we will be finding left hand limit. So let me do question 17. Limit x goes to minus 2 from right side. It's x plus 3 into x plus 2 absolute divided by x plus 2. So what will we do? We'll just replacing limit with h goes to 0 and replacing x everywhere minus 2 plus h plus 3 minus 2 plus h plus 2 divided by minus 2 plus h plus 2 with condition h should be greater than 0. So in this case what happens, we just cancel these together. H goes to 0, it will become 1 plus h, and then we cancel these together. We get h absolute divided by h because these two will be cancelled as well. Now h is greater than 0. अगर h greater than 0 है तो उस केस में हमारे पास जो h absolute है that would become simply h dividing by h. We cancel these together and then just put limit h goes to 0. That would give you answer is 1. If we find left hand limit x goes to, in part B, that was part A. So if you want to find limit x goes to minus 2 from left side, x plus 3 into x plus 2 absolute divided by x plus 2. So it would become limit h goes to 0, x plus 3, that would become now minus 2 minus h plus 3 absolute minus 2 minus h plus 2 minus 2 minus h plus 2. These two will cancel each other. So we get limit h goes to 0. We can cancel these two as well, minus 2 and plus 2. This become minus h plus 1 absolute of minus h divided by minus h. Now h is positive, so we know that this is a rule that x absolute is same as minus x absolute. So h absolute and minus h absolute will be same as well. So you would write minus h plus 1 into h absolute divided by minus h. So limit h goes to 0 minus h plus 1. This will become h divided by minus h. So we get cancel these two together. So we have in this case minus 1. So you see left hand limit is minus 1 whereas right hand limit is plus 1. दोनों बराबर नहीं है तो इस फंक्शन का जो लिमिट है वो एग्जिस्ट नहीं करेगा. Is that right? I presume it's clear to everybody. So the same thing will be done in question 18 as well. I'll just ask you to pause the video and solve question number 18 just to practice it. It's almost similar method will be used here. Let me consider question number 20. You do question 19 yourself once I do question 20. So in question 20, what do we do? In part A, we first find limit x goes to 0 from right side 1 minus cos x divided by cos x minus 1, and then we have absolute. Okay, so we can simply compute this value like limit h goes to 0, and that will become as 1 minus cos 0 plus h divided by cos 0 plus h minus 1 absolute, which will become limit h goes to 0 1 minus cos h divided by cos h minus 1 absolute. Now keeping in mind the value of cos is always less than or equal to 1. So as h goes to 0, this value will be less than 1. So if this is less than 1, it means cos h minus 1 is less than 0. When this is less than 0, it means this absolute will give you what? This will give you minus value. So we get 1 minus cos h divided by minus into cos h minus 1. ये मैंने वही एब्सोल्यूट का जो कंसेप्ट है उसको यूज़ किया है कि दैट इज इक्वल टू माइनस एक्स व्हेन एक्स इज लेस देन 0, इट इज़ प्लस एक्स व्हेन एक्स इज ग्रेटर देन आर इक्वल टू 0. तो यहाँ पर cos h माइनस 1 की वैल्यू हमेशा के लिए 0 से कम होगी, बिकॉज cos जो है वो 1 से ग्रेटर हो नहीं सकता. सो cos h minus 1 that will be negative, so we can simply cancel this together. 1 minus cos h, and this is minus cos h minus 1, so in this case the limit will be simply 1. Exactly same thing will be used in this one as well. In this case cos x minus 1, and this is cos x minus 1 absolute. So cos x minus 1 absolute is obviously again it will be negative, so that will give you minus 1. So this limit will be minus 1 in this case. Okay, so you can do that yourself, I presume. Just pause the video and try to do it. In question 21, 22, we are using greatest integer function. So I hope you must remember from greatest integer function we have a rule that a plus h that is equal to a, whereas a minus h that is equal to a minus 1. So using this concept here in question 21, if you want to find limit theta goes to 3 from right side greatest integer theta divided by theta, that will become as limit h goes to 0, this will be 3 plus h divided by 3 plus h. Now as I written above, so this will become what? Limit h goes to 0, this will become 3, नीचे आ जाएगा 3 plus h. So then applying limit h goes to 0, it gives you 3 divided by 3, that is equal to 1. तो इसका जो right hand limit है वो 1 के बराबर है part A में. Whereas in case of part B, if you want to find limit theta goes to 3 from left side greatest integer theta divided by theta, so we just replace limit with h goes to 0, and this will become 3 minus h greatest value, and this will be 3 minus h. So we have in the numerator it becomes h goes to 0, it's a minus 1, so we'll be getting 3 minus 1 divided by 3 minus h. So that is limit h goes to 0 it will become 2 divided by 3 minus h. Applying limit h goes to 0, so we will be getting 2 divided by 3. So the left hand limit is 2 divided by 3, whereas right hand limit is 1. The same thing we do for least integer as well. उस केस में फिर हमारे पास a plus h जो होता है least integer का, ये बराबर होता है a plus 1 के, whereas a minus h value, that will be same as a. The same thing will be done in this one as well. Just replace division को replace कर दिया हमने किसके साथ, minus के साथ, बाकी same कहानी होगी. So I hope it's clear to everybody. If you have any question, you can just put that question in comment box. Don't forget to share with your friends and to like and subscribe to my channel. Thank you very much. See you in next video.